how do you identify appropriate sizing of your compute in production environments? What would be the process to see if you are actually setting things up for the right level?
Sure. I mean, so this is often difficult for sort of startups early on in their journey because they don't really know what to expect. There's a lot of uncertainty about traffic expectations and so forth. And I can count on every startup CTO that I've spoken to about their demand has shown me a ridiculous hockey stick graph and said, we're going to do this, which is obviously not generally accurate. So really, the thing is about modeling. Really, so have a think about what does your general usage patterns look like? Can you build load testing scripts to exercise your infrastructure at that level, and then do some science, right? Do some proper actual kind of numbers-based engineering where you throw some of that traffic at your platform, use the metrics that you're gathering from the monitoring that you've set up properly, which is another thing that people often sort of skip out on, and use that to right-size those instances. People who are doing this less well, which is to say almost everyone, either sort of throw cheap instances at the problem and then kind of make them bigger every time things blow up, or throw enormous instances at the problem and sort of defer having to think about scaling until they find the problem later. But load testing will uncover things that can't just be solved through throwing capacity at the problem. So things like database deadlocking and bottlenecks and those sorts of issues. So really, we advocate for a proper operational readiness period of time where you can load test against the traffic you're expecting to see and scale up accordingly with a good understanding of what is the best instance size to use.
Yeah, absolutely. I mean, quite often I've taken the consideration of if we need more capacity, I'll throw money at it, throw extra resources, and it'll just bigger instances, it'll handle it until we need to worry about scaling.
And that's a reasonable approach. Like I think it's often a good thing to do that rather than spending the engineering hours that might actually be more expensive on solving the problem properly. But sometimes there are problems that you can't just solve by throwing additional tin at it, and that's where you need to get more scientific around it.
Sure. Rob, anything to add on how do you appropriately size your compute?
Yeah, certainly. Also, I'm kind of reminded of when I was a developer and I spent a significant amount of time optimizing a loop. That was not run very often. So, definitely having a good awareness of what your value of time is super important. So often at the beginning, it may not be the wrong thing to do just to put an amount of compute against a particular application or endpoint and see how it goes. As you start scaling or if you start increase the number of instances, that's probably the time you should start looking and thinking about it. And then, the way that you approach that can be pretty nuanced. I think you've described a lot of it, but it goes even further as well. So if you think about in containers, there's kind of interesting sizing characteristics that happen there because you get the size of the instance, but then you also have the size of the container itself. And if you do not size correctly the size of the containers, then you'll end up filling up your instances and you won't have anywhere to allocate and place your containers into it. So sometimes people will try and almost scale horizontally, let's say too quickly. And what I mean by that is if you have a JVM, there's quite a big footprint that comes with that. So to have a JV up and running, you need a significant amount of RAM, and that's probably going to be a constraining factor on an instance. So if you've got an instance without that much RAM and you're trying to add as many containers as quickly as possible, you're probably not going to be very efficient on the CPU side of things. Then if you go almost the opposite end of the spectrum and think about Go, you tend to be CPU constrained. The memory is very efficient, so the amount of memory used is going to be really low. So then you're going to run out of CPU. So having an idea of where that sits. But the thing is, sometimes people do not actually size the instances correctly. So I would say if you've got a container, you've sized it at 1 CPU and 4 gig of RAM, that doesn't sound like you've gone through much of the maths or the science that's been described earlier. So really kind of run different tests and see what is a good sizing increment or scaling increment. The smaller that is, the more granular and efficient you are with scaling. But sometimes if you go too small, you're actually going to be inefficient with the amount of baseline resource you need to run something. So definitely take that into account as well.